Hi everyone. So we will discuss very interesting classical problem that's called as Tower of Hanoi. Okay. So you can see this diagram. So the problem is related with this game. So there are some rules of this game. So the rules is like this. Okay. So let me tell you what you have to do is. So in this game there are three towers. You can name these towers as, let's say, A, B, and C. So goal is to move all the disks from tower A to C. Okay, so we have to move all disks from A to C, but during this process we can pick one disk at a time. Okay, so that is the task we need to do, but rule is you can pick one disk at a time and you cannot place a bigger disk over a smaller disk during the movement. Okay, so cannot place a big disk on small disk. Okay, so these two rules must be followed while doing movement of the disks. Okay, so now we have lot of disks, but let us try to start with a very small problem in which we have only two disks. Okay, there will be n number of disks in the tower numbered from, let's say, 1 2 3 4 5 up to n, but let us say we will try to first do it with two disks only. So let us have two disks and let us try to move these two disks. Okay, so what steps you will follow? You will first pick disk number 1, you will put it here. Okay, so after the first step you can say this is ABC. You can put the first disk here and then you can put the second disk here. Okay, so 1 comes here and 2 comes here. So this is after two steps. Okay, and in the third step you can just pick one and put it here. So it will become something like this. Okay, one followed by two. So you saw you actually needed three steps for two disks. Okay, so let us try to do it for the case when you have n equal to three disks. Okay, so you can try it yourself. It's like a game. You have to think what operations we should do. So this is our initial state. So what I can do, I have three disks. I can first move these two disks on some other tower. Okay, I can try to move these two disks here and then I can move the third disk here and then I can do it on so on. Okay, so if you need to move two disks from this part to this part, what you will do, you will follow similar steps as you done in the case n equal to 2, except there is one difference. Instead of moving the top two disks from A to C, we are now moving top two disks from A to B. So that means these operations will be executed in a on different stands. Okay, so you can assume we have exchanged the stands B and C and we are going to do the same operations now. Okay, so let us first try to move the top two disks. So what I will do is I will put disk number 1 here, so 1 comes here. I will put disk number 2 here, so after two steps 2 comes here and 3 remains here. Okay, in the next step I can put 1 here. Okay, so that makes 3 steps till now. Okay, so one goes from here and we can put 3 here. Okay, so that is 4 steps now. So what is the state after 4 steps? We have disk number 3 here and we have disk number 2 here and disk number 1 here. Okay, now we need to move these two disks here. So what we will do, we can first put 1 here. Okay, so 1 comes here, that is the 5th step, and then we can say okay, we will put 2 here. Okay, so that is the 6th step. Okay, 2 comes here, that is after 6 steps, and finally we can put 1 here. Okay, so that is after 7 steps. So you can see finally we are able to put all the three disks in the stand after 7 steps. Okay, so for n equal to 3 we actually needed 7 steps to do the work. So you need to think, you need to print all the steps. Okay, for a given value of n. So now this is where recursion is going to help you. So what we can do is, So let us now try to solve this problem recursively. So let us say we have 3 stands and we have disks, like lot of disks here. Let's say these are numbered from 1 2 3 up to n, and let us try to break this. So what we can do is we can assume if we can move n minus 1 disks, then our work will be easy. Okay, so what we can say is we can make a function, we can make a recursive function. Let's say move is a function. We can ask move function to shift n minus 1 disks from a to c. Okay, let's say this is a, b and c. So we can ask this function to move n minus 1 disks from a to b. So what will be the state now? You will have one disk here and you will have n minus 1 disks on b. Okay, so this is n minus 1, and then you have one disk in this stand a. So what you can do, you can just move this disk from a to c. So since it is a one disk, you can simply shift it. So you can you can say shift the nth disk from a to c. Your work is done, and then you can just call another function. Okay, you can say, okay, if this disk is shifted, so I will just erase this. So now you have the nth disk here, and what you can do is you can actually move n minus 1 disks from b to c. So you can call move n minus 1 disks from b to c. Okay, so this is recursion. So this is recursion. It will automatically do the work. It will automatically do the movement of all the n minus 1 disks from b to c, and you can see during this process it will not violate the property when we are placing a smaller disk over a bigger disk, because the disk at the bottom is a bigger disk. Even if you place any disk from this stack in this disk during the process, it will make sure that we are not placing a bigger disk over a smaller disk, because the disk at the bottom is already the biggest. Okay, and we will be recursively moving all these disks one by one, because we have seen if we can move n equal 2 disks, we can actually move 3 disks also. If we can move 3 disks, then we can move 4 disks also, and if we move 4 disks, we can move 5 disks also. Similarly, we can assume that n minus 1 disks can be moved recursively, and that's it. Okay, so this is the solution to the problem. So we will first write the code, and then we will also draw the recursive diagram to print the solution. Okay, so let's write the code. Okay, so we will take input the value of n, and we will make this function called void move that gets the number of disks, and also we should give the names of the towers. Okay, so I can just call move n disks from, let's say, tower a. So here I'm taking 3 towers. Let's say char source, char destination, and char helper. Okay, so what is we are going to do? So suppose you have 3 towers, let's say a, b and c. So our task is to move the disk from the source to the destination. Okay, so the destination is going to be b. Okay, sorry, destination is going to be c. So we can also change the order. We can say, okay, helper, and we can say destination. Okay, so we can say the towers are a, b and c, where a is the source and c is the destination. So now we have to think of base case, and we already know the recursive case. Okay, so the base case would be if you have 0 disks, then you do not need to do anything. So if n is 0, you can just simply return. Okay, or you can, if you do not want to make this as a base case, you can also make a base case for 1, in which you have to move 1 disk from the source to the destination. That is also fine. Okay, let's see in the recursive case. So in the recursive case, our first step is to move n minus 1 disks from source to helper, not to the destination but to the helper. Okay, So let's see what steps we need to do once again. So in the first step, you will pick these n-1 disks and you will put them on B. Okay, this is what you do. And the nth disk remains here. So this is the first step. Okay, so that means your destination would become B. So you call the move function, number of disks is n-1, source remains same, helper we will see, and the destination is nothing but the previous helper. Okay, so we are exchanging the names of destination and helper, so it becomes destination at this particular point. Okay, and after that, what you have one disk. Okay, so to move one disk you do not need recursion, you just need a print statement. So it says, okay, let us take this disk from A to C. So A is your source, C is your destination. So that's what we are going to print. So this is your second step. So we can say cout shift disk disk number n from source to destination. That's it. And what is your next step? So next step is move n-1 disks which are lying on B. So what is B here? So B is nothing but helper. Okay, so pick those disks from the helper. Where do you want to place those disks? You want to place those disks on destination. So basically source and helper are exchanged. Okay, so that's it. So you're moving n-1 disks from the helper, that is B, to the destination, that is C, using source as a helper. Okay, so that's what we do in the third step. So this is your third step. Here you pick these n-1 disks, you put them here. So this is how all your disks are moved. Okay, so let's run this code and see. Okay, this should be 4. So we should give an input. So you can see we are getting some answer. So let us run this for a smaller value of n. Okay, so if you do not give any input, n will take a garbage value and that can lead to segmentation fault. Okay. Okay, you can see for n equal to 3, we are getting this answer and we can actually verify that this is going to be a correct solution as well. Okay, so let me explain you why this code works and how it works. Okay, let us quickly verify all these steps. It says shift disk 1 from A to C. So we move this disk here. So 1 comes here, 2 from A to B, 2 comes here. Then says 1 from C to B, 1 comes here. Then it says 3 from A to C. So it becomes like this. 3 comes here. And then it says it is 1 and 2. So it says 1 from B to A. So 1 comes here. It says 2 from B to C, 2 goes here. So now final state is like this. And it says 1 from A to C. Okay, so you have one disk here which you put here. And now we will try to visualize recursion, how it happened. Okay, so what we will do, we will, let's say we will draw the diagram here. Okay, so we have a function called move in which we are getting 3 disks and we are getting the names source, helper and destination. So we are getting A, B and C. Okay, so from here we actually performed 3 steps. One is move n-1. So we made a call on move function. So we have made this call move 3 disks from A to C using B as a helper. Okay, so this is what we have. Now in each recursive call we are doing 3 steps, 1, 2 and 3. So let me try to draw these 3 steps. So in the first call we make move, source remains same, and we exchange destination and helper. So we basically exchange these two parameters and we make a call on n-1. So this is 2 and this is A, C, B. And as you know, recursion is making new function calls in which we are passing these values by making a copy. Okay, so in the new function call you have ACB as a parameters in the function call. Then we execute second line, that is shift disk from. Okay, so this will be executed once this function call is over, so we will first elaborate it as well. So it will execute shift disk n, so n is 3 in this function, from source to destination. Okay, so from A to C, that is what it will print. Okay, and finally it will make a call on move n-1, so n is 3, so it will be 2, and you can see helper and source are exchanged, destination remains same, so we basically exchange these two in the next function call. So it becomes 2 B, A, C. Okay, so this is what we do. Now we need to elaborate each of these function calls. So similarly, from this function call we will make a call on move. We will say okay 1, followed by, we will exchange these two. Okay, we will exchange these two, so it will be A, B, C, and then we will print a statement shift disk number 2 from A to B. Okay, from A to B. So A is source, B is destination, so that is what we do here. And then we will make a call on move. We will say 1 and we will exchange the first two. It will be A, C, A and B. Okay, so now let us try to first extend this function call. So it will make a call on move of 0, so that is a base case. We will not do anything here. Then it will execute a shift statement. So it will say shift disk 1 from A to C, source to destination, and it will make a call on move disk 0. So that is also a base case. We will not do anything. So this is not a call, this is a statement. So we come to the next function call, which is this. So it will make a call on move of 0. It will print a shift statement. So shift disk n, so n is 1 here, from source, that is C here, to destination, from C to B, and it will make a call on move of 0. Okay, so now we come to the next function call, which is this. So from here we will make a call on move of 1. Okay, parameters will be B, C, A, and from here we will make a call on move of 0. From here we will do a shift statement. So shift disk 1 from source to destination. Okay, so it is B to A, so we will say shift disk 1 from B to A. Okay, and then we will make a call on move of 0. That is also a base case. And from here two things are left. We will first print a shift statement. So shift disk what, n is 2 here, from B to C. Okay, from B to C. Okay, and here we will make a call on move disk n-1, which is 1. And as you can see in the third call, what we do, we basically exchange the first two parameters. Okay, so we exchange B and A. It becomes move 1, A, B and C. So it will again initiate 3 steps. One is a recursive call that leads to a base case. Then we have a shift statement. So shift 1 from source to destination. Okay, so source is A, destination is C, and finally we make a call on move of 0. Okay, so that is also a base case from where we actually return. So this is the entire recursion tree for the Tower of Hanoi problem. Now if you want to verify what steps have been executed, so you can clearly see the recursion tree executes in the left to right order. So firstly we will go into this branch that will execute this step. So this is the first step, shift disk 1 from A to C, which is correct. Next is this step, shift disk 2 from A to B, which is correct. Then the third is this step. Okay, we come in this branch, we go in this branch, shift disk 1 from C to B, which is correct. Then shift 3 from A to C, which is correct. Fourth is 1 from B to A, correct. 2 from B to C, 2 from B to C, and finally 1 from A to C, 1 from A to C. And you can see these are the steps: 1, 2, 3, 4, 5, 6, 7. So this is how we are able to solve this Tower of Hanoi problem using recursion. And you must be able to draw and understand this tree for other problems as well. Okay, so you can see if if we have done this question iteratively, it would have been very difficult for us to um, implement it as well. Okay, but this can be done using by taking a stack, but the implementation would have been much more complex. Okay, but this is the beauty of recursion. You can just do a lot of complex tasks by writing few lines of code. So that's all for this video. Thank you.